Hello, I'm George Percival. Allow me to spend a few minutes with you talking about how AI, artificial intelligence, is changing the way we think about space. These developments are based on the work of the IEEE and the Spatial Web Foundation. Space is a fundamental topic with a long history extending back to antiquity. A relatively recent comment comes from Henri Bergson in 1899, who roughly said, "We talk in words, but we think in space." The World Wide Web has done much to allow us to express ourselves in words and documents and exchange those items. Now, we'll use space as an organizing principle of the spatial web. This talk is broken into two parts. First, we'll look at some new ideas about space coming from AI. Second, we'll show how those ideas of space are used in the spatial web. Let's begin by looking at some recent technology. Ideas about space are coming from development like automated vehicles, augmented reality, Internet of Things, Web of Things, robotics, and digital twins. Each development is relevant to agents acting in space. Here we will focus on AI and machine learning. Let's review advances in AI that are leading to spatial intelligence. AI has been around for decades. Let's pick up the story in 2012 with the third generation of AI. In that year, the ImageNet large-scale visual recognition challenge triggered a resurgence of AI. ImageNet is a large database of images that are tagged. The challenge for computer vision was to put labels on those features in the images and confirm their accuracy. The challenge was solved using big data processing and convolutional neural networks. CNNs have an amazing ability to label images at scale with high accuracy. AI was able to identify objects in the images, objects we might call features or domains. The spatial aspect here is computing that is done in very high dimensional and non-coordinate spaces. We are now seeing convergence in these spatial representations. Researchers are seeing commonality of structures for scenes observed by different CNNs. This convergence is a shared statistical model of reality, a common geography. Commonality of images in hyperspace is amazing, but what about activities in time? The same group that created the ImageNet database is now building the behavior database. This is a collection of labeled videos for the identification and representation of behaviors. The behavior database is designed to be used by AI developers to spur competitions in activity identification. Now, we see actors and activity becoming first-class objects, just like features were for ImageNet. But vision involves a much higher dimensional spaces, and time now includes actors perceiving the passing of time. We anticipate a similar convergence of AI models for vision. Spatial intelligence emerges from this being in the world. Going beyond images and videos, AIs are interacting with the physical world. AIs are deployed as cyber-physical systems. This is embodied computing that can see, learn, and do. This is intelligence that learns and reasons about objects, places, and events in space and time. Often, these are autonomous agents. The agent may change its goals without human intervention. Here also, we see a convergence of natural and artificial intelligence. In 1948, Edward Tolman showed how brains develop cognitive maps that are analogs of physical spaces. More recent is the work of Carl Friston, a neuroscientist who identified the free energy principle, which describes how intelligent agents act in the world. These developments provide us the basis for structuring networks of spatial intelligence. We go beyond the networks of words and documents that is the World Wide Web to be able to think interactively about space. Here, we enter the second part of my talk about the spatial web. The spatial web concept was pioneered by Gabriel Rene and Dan Mapes in 2019. Building explicitly on the concepts of the World Wide Web and anticipating a rapid growth of AI, Dan and Gabriel sketched out the vision of the spatial web. Now the Spatial Web Foundation is working with IEEE to engineer and build the spatial web. Last year, the Spatial Web Foundation teamed up with the Denton's legal firm to sketch out the future of AI governance in the spatial web. The document describes approaches to governance for various types of intelligence agents and approaches to treating law as executable code. The IEEE P2874 Spatial Web Protocol Architecture and Governance Standard will be published later this year. Let's take a look at the spatial concepts of the spatial web. Here we see the conceptual model of the spatial web for agents in hyperspace. At the base is a framework of hyperspace and time, including our expanded notions from AI. Domains are entities that persist with identity over time. Geographers call these features. Agents and activities describe change based on time in hyperspace. Here the agents have agency. They exhibit intelligence, have goals, and interact with the world. Governance of agents is based on structured representation of credentials, norms, and contracts. Here we see a summary of hyperspace. Space is defined here as elements related by paths. This very abstract definition of space allows expression of space in many forms. On the right, coordinate systems and manifolds are typical for physics and geodesy. AI is based on very high-dimensional vector spaces that allow comparison of abstract concepts, apples and carrots. Graphs and linked data are also used extensively in AI with very large graphs and hypergraphs. The spatial web seeks to define a common interface across this diversity of hyperspace using the mathematics of category theory. One example of the value of hyperspace is to see how domains may be represented in different types of space. Here we see an embedding of geographic space into hyperspace. On the left is a coordinate space for the surface of the Earth. That same surface can be modeled as a cellular space in a discrete global grid. The DGGS comes with an index on the cells and is represented as a graph or a hypergraph. The graph of the Earth's surface is then embedded in the larger graph of concepts in the spatial web. Extending space in this way to the spatial web serves as a basis for a geography of hyperspace. The spatial web is composed of a graph of graphs. The universal domain graph is built from existing and future graphs. There are many large knowledge graphs today. We seek to make those knowledge graphs more accessible and to provide a greater ontology for the graphs. The simple diagram betrays the size and complexity of the UDG. Connecting existing knowledge graphs must embrace the heterogeneity of those graphs. There needs to be well-defined interfaces at the boundaries in the graph. Domains in the UDG are the persistent entities on which spatial web agents act. Agents in the spatial web have a range of intelligence. Here we present an agent that has agency. The agent interacts with the world, represented here as domains. The agent creates an internal model of the world. Based on the goals and that model, the agent takes actions. The spatial web provides the messaging abilities for actors to act in accordance with norms and laws and to form contracts with other agents. A summary of the spatial web concepts are represented as an ontology. The spatial web ontology was built upon careful examination of several existing ontologies. The ISO IEC top-level ontologies, a Common Core ontology, a Sumo upper ontology, and the IEEE ontology for ethical robots. All entities in the ontology get encoded in the spatial web's hyperspace modeling language, or HSML. HSML is exchanged using HSTP, the Hyperspatial Transaction Protocol. HSTP and HSML are two core standards of the spatial web. In summary, the spatial web is an ecosystem of agents. Here, we recite a one-sentence summary of the behavior expressed using the spatial web. Intelligent agents with credentials performing activities discussed in channels on and in domains represented in hyperspaces in order to fulfill contracts with other agents. While this talk has focused on some technical aspects of the spatial web, the bigger picture is the benefits of the spatial web will provide as a world rich in AI and spatial information. Building the spatial web is the future of computing.